Hi everybody, happy Monday. I'm sorry that I'm not with you, but we are going to have a video that'll be very much like class. We're going to do two problems out of the book on this notebook papers, 87 and 90, and then we're going to do some of the problems together for 99 to 106. I really believe that the first few are super easy and that I would really like to make sure that you guys could do those on your own. So for the first few, I'm gonna let you guys do those on your own, but for some of them are kind of tricky, so we'll work on those together. Okay, so first we're going to work on problem 787, and we're going to investigate the hilarious situation, which is angle side side. And in math 1 and math 2, students are always like, ah, angle side side. Okay, well, notice it wasn't one of the congruence theorems that we used for our triangle proofs or triangle flowcharts. And it's not because it makes a bad word, it's actually because it doesn't work. So today I'm going to show you kind of why that does not work. Now this looks like a pretty harmless law of sines problem. I have an angle and a side across, and a labeled angle, but it's x, and a side across. And so I'm going to do the law of sines. These two are going to get paired up. These two are going to get paired up. And I have sine of 40 degrees over 5 equals sine of x degrees over 7. And then I'm going to cross multiply, so I have 5 times sine of x degrees equals 7 times sine of 40 degrees. Divide by 5. And I'm going to do this on the calculator to get something to put there, but remember, to avoid rounding error, you're going to want to leave this answer in the calculator. So 7 times sine 40 divided by 5, 0.8999. And then I'm going to sine inverse both sides to get x by itself. On the calculator, however, I'm going to do sine inverse of answer because I want to avoid rounding error there. And I have 64.15 degrees. Okay, that looks all well and good. And you're like, what's the problem? Is law of sines work? Yes, it worked. But here's an interesting fact. I want you to notice that I have angle side side, but there's actually another possibility. What if 7 was the long side? Okay, this is not any different from what I have, but I'm now, instead of 7 and 5 and then the long side, I have put 7 on the long side, which means that this angle needs to be bigger than 40, which is not a problem here. However, this angle, if you notice, is actually obtuse. And how you would actually get that angle, which we don't really do in Math 3, we do a lot of this in pre-calc, is take 180 minus the angle that you got from law of sines. because take a look at this. This is going to make a linear pair. That's going to make 180. And 180 minus 64.15 is 115.85. There are actually two correct answers. One of them where 7 is on the medium side, and one of them where 7 is on the long side. Where 7's on the medium side, your angle comes out to be 64.15. When 7's on the long side, it comes out to be 115.85 for the angle across. So because there's two possibilities, you can't have a congruence theorem because you don't really know if they're congruent. Okay, what does that mean for you? That means for you, when you guys have find an angle side-side problem, you could actually say, no solution. I can't solve this, or not solvable, because you don't know which one it is. You don't know if 7's on the medium side or 7's on the long side. This topic, we're not going to give this to you on a test or anything like that. This topic is a pre-calc topic, and so this concept will be studied in much greater detail in pre-calc, and they give you rules on how to tell which one is which and if there's going to be two answers or one answer. So don't worry about it for now, but it's just very interesting that angle side-side really isn't a congruence theorem because you're not really sure if they're congruent. Okay, number 90. And remember, feel free to pause me at any point to write down anything you need to write down. Okay, the goal for number 90 is to kind of pick out which strategy to use and solve for x. So it looks like this one has two different sets of angles with sides across. So that would be law of sines. Okay, and I have sine of the angle over the side across equals sine of the angle over the side across. Cross multiply. Divide. .9. Okay, B. I've kind of thrown this in there to kind of throw you off. This is a right triangle, and if I want to find that, I'm going to use tan. This is opposite and adjacent, which is TOA. Tan of x degrees. I don't know what that little dot's doing there. I think I was trying to inverse too soon. Equals opposite over adjacent. And then to get x by itself, you tan inverse both sides. Okay, remembering how to plug that in. So tan inverse 5 over 9, 29.1. Okay, Now for C, notice I have side angle side. Whenever you have side angle side, you're going to want to use law of cosines. Because I can't really set up the proportion, I'll have too many variables in it. I don't have an angle and a side across that both are measured. So, law of cosines is x squared equals 8 squared plus 11 squared minus 2 times 8 times 11 cosine 16 degrees. And remember, this is always with the angle, so across from each other. They're always paired up on all of these problems. And remember, type this straight into the calculator the way it looks in one step. Just type it in. Your calculator knows order of operations. It will not steer you wrong. 15.8. And then to avoid rounding error, I'm going to do square root answer. And that's about 4. Okay. Now we're going to move to the resource page, and the first 4 are extremely easy. They are just like number 90, so you need to figure out which tool to use. So let's read the problem and we'll label it and decide which tool to use, and then I'm going to let you finish the problem and we will post an answer key so you can check your answers. Okay, so the first one, number 99, a bridge is being designed to connect 2 towns, one at point A and the other at point C, along the shores of Lake Tofty in Minnesota. Levon has the responsibility of determining the length of the bridge. Since he cannot accurately measure across the lake, which is AC, he measures the only distance he can by foot, AB. He drives a stake into the ground at point B and finds that AB equals 684 feet. He also uses a protractor to determine that measure of angle B is 79 degrees and measure of angle C is 53 degrees. How long does the bridge need to be? Okay, so the bridge is going to go across the lake, so it's going to be here. Notice I have an angle and a side across, and an angle and a side across. So this is a law of sines problem. And I'm going to let you finish that law of sines. Okay, number 100. Lake Tofty, part 2. Levon is not convinced that his measurements from problem 99 are correct. He decides to calculate the distance again between towns A and C using a different method to verify his results. This time he drives a stake into the ground at point D, which is 800 feet from town A and 694 feet from town C. Okay, so D is 800 feet from town A. It's a B. They must have updated the ebook. Okay, well that's alright. We're just gonna change that to D. People must have gotten confused. Okay, it's 800 and 694 feet from town C. He also determines the measure of angle D is 68 degrees. Using these measurements, how wide is the lake between points A and C? Does this process confirm the results from problem 799? Well, I'll let you figure that out, but this is side angle side. So you want to use law of cosines, and I'm going to let you finish that with the law of cosines. Okay, number 101. The lid of a grand piano is propped open by a supporting arm, as shown in the diagram below. Carson knows that the supporting arm is 2 feet long, okay, and makes a 60-degree angle with the piano. He also knows that the piano lid makes a 23-degree angle with the piano. How wide is the piano? Okay, so we actually want to know how wide the piano itself is, so this part is x. And it looks like I have an angle on the side across, but I could also get that angle with triangle angle sum theorem. So I'm going to mark this just as a reminder for you guys to find that angle, and then you'll be able to set up the law of sines proportion. Okay, 102, pennant race. Your basketball team has made it to the semifinals and now needs to win only 2 more games to go to the finals. The team's travel plan is to leave Philadelphia and travel the 138 miles to the town of Euclid to play the team there. The team will then leave Euclid, travel to Pythagoras, these are mathematicians by the way, and play that team. Finally, the team will travel 97 miles to return home. Your team bus can only travel 300 miles on 1 tank of gas, assuming that all the roads connecting the 3 towns are straight and that the 2 roads that connect Philadelphia form a 28-degree angle. Will 1 tank of gas be enough for the trip? Okay, I'll let you figure all that out, but this is side angle side law of cosines. Okay, so those were not too bad. Getting into number 103 to 106, however, these are a little bit harder. 106 is not bad, but 103 to 105 are a little bit spicier. Shante is buying pipes to install sprinklers for her front lawn. She needs to fit the pipes into the bed of her pickup truck to get them home from the store. She knows that the longest dimension in her truck bed is from the top of one corner of the bottom of the bed. Top of one corner to the bottom of the opposite corner. Okay, so this, you kind of have to picture this as 3D. This is the top left connecting to the bottom right. After measuring the truck bed, she draws a diagram at right. What's the longest pipe she can buy? Okay, and you know we've all done this. You know, when you have something long to put in something, you kind of jam it in there diagonally. Okay, what we're going to do first is just concern ourselves with the floor of her truck. So I'm going to draw in the diagonal of the floor of her truck, and I'm going to put a right angle symbol here. So what I would like to do is find the length of this diagonal on the floor of her truck, and the easiest way to do that is Pythagorean theorem. Actually, this is the height. Okay. This is 40.4. 40.4 is this, which is also this. Good thing I looked. Okay. 40.4 squared plus 72.3 squared is 6,859.45, and then square root both sides, 82.8 equals C. Okay, so if I can teeny tiny, maybe I want a different pen. I want a different pen with a little bit thinner. 82.8. Okay, now what I'm going to do is make a right angle here and make Pythagorean theorem again with this right triangle, the diagonal of the bottom of the truck, the height of the truck, and then how long this pipe can be. And I know this is yucky because we're using a rounded number in a calculation, but hopefully she will be smart and make her pipe a tiny bit shorter than what we calculate. Square root both sides. So 84.2 inch pipe or less. And 84 inches is about 7 feet, so 7 feet or less. That one is fun, but it's kind of out of nowhere. Okay, 104. You know that if a triangle has two angles of equal measure, then the triangle is isosceles and has two sides that are the same length. Now use your triangle tools to prove that if a triangle has two angles with equal measure, then it has two sides of equal length. For example, for PQR, show that if Q equals R, then PQ equals PR. Okay, so what we're going to do with that is we are going to set up the law of sines, because this is not a right triangle. So we're going to do sine of Q over PR, so sine of the angle over the side across equals sine of the angle over the side across. This and this. Okay, now I'm going to cross multiply. And proper proof is going to have a justification over here. Okay, now what I'm going to do is called the substitution method. I know that Q and R are equal, so I can actually change one to be the other. PR, that's supposed to be PR, times sine Q equals PQ times sine Q. I changed R to Q because those are equal. That's called substitution. And now I'm going to use a division property. And voila, I have PR is equal to PQ. You guys are like, I probably would not have come up with that on my own. And I realize that. That is definitely challenging. Okay, 105. As Frida gazes at the edge of the Grand Canyon, she decides to determine the height of the wall opposite her. Using an app on her phone, she determines that the top of the wall is a 38-degree angle above her, while the bottom is a 46-degree angle below her, as shown in the diagram at right. If the base of the wall is 253 feet from the point on the ground directly below Frida, determine the height of the wall opposite her. Okay, so what we're going to do is estimate that to be a right angle. And if this is 253, then this is also 253. Should I use my other pen? And because you have two different right triangles, you can use tangent to find x, and then tangent again to find y, and then add them together to find the height. And I am going to let you guys finish this one because this is Math 2 and it'll be a really, really good review for you. Okay, and this last one I'm also going to let you finish, but let's start it. While facing north, Lisa and Aaron decide to hike to their campsite. Lisa plans to hike 5 miles due north to Lake Tofty before she goes to the campsite. Aaron plans to turn 38 degrees east and hike 7.4 miles directly to the campsite. How far will Lisa have to hike from the lake to meet Aaron at the campsite? Start by drawing a diagram of the situation. Okay, so Lisa's going to go to the lake, which is here. And Aaron's going to go directly to the campsite. There's my little fire and my little tent. And what you want to know is how far Lisa's going to have to hike from the lake to the campsite. This one is beautifully set up side angle side, so you have a lot of cosines. And I'm going to let you guys do that because I know you can. Alright everybody, thank you so much for watching. I hope that was helpful. I hope that law of sines and law of cosines is really starting to make sense. And I will see you guys on Tuesday.